The following video is a walkthrough of the steam and water cycle, as well as some of the other functions of a power plant. The following diagram shows the steps in which water is prepared, boiled into steam, and condensed back into water after passing through the turbines. Water is represented by blue arrows, while steam is represented by red arrows. The initial supply of water is pumped into the system and charged to efficiently remove pollutants and non-condensables. This passes through the feed pump, which supplies pressure through the system, although there are many other pumps throughout the system. The deaerating feed tank removes dissolved oxygen from the condensed water so that it can be sent back through the system. It also preheats the water, stores it, and creates a head pressure for the system. The economizer increases the efficiency of the plant by using excess heat produced by the boiler to further preheat the water. Preheating the water also decreases the thermal shock on the boiler. After this, it passes into the feed regulator valve, which regulates the flow and controls the water entering the boiler. The boilers at the Spring Creek Power Plant are D-type boilers, which are a common type of water tube boiler. Water tube boilers consist of a furnace made up of water-filled tubes. High-pressure water is pumped through the furnace into the steam drum, directly above the boiler, where the saturated steam is separated from the water. Some water is then pumped down into the mud drum, which is used to collect any non-condensable gases or solids for later removal. The superheater heats the steam past the point of saturation so that it can now safely pass through the turbine. Superheaters are similar to economizers, except that now it is steam that is being heated instead of water. The superheated steam now passes through the turbines, which produce electricity for the plant and surrounding area. At this point, the steam is condensed back into water for efficient transportation. The condenser also creates a pressure differential between itself and the superheater, which allows steam to flow more easily through the turbines. At the end of the cycle, the water is pumped back to the start of the cycle. If no leaks are occurring, then no additional water needs to be added to the system. Outside of the plant, the water is pumped through buildings in the surrounding area. Hot water is pumped in the winter for heating, and cold water is pumped in the summer for air conditioning. This schematic shows the piping system for one of the 6 loops in the Spring Creek campus. The water is pumped into a garage in one of the buildings, which has its own pumps to supply pressure to the rest of the loop. These pipes are prone to leaks and need common maintenance or replacement to keep up with this.